Hello, hello. Happy Saturday. Here we are, back again. Game deving for the weekend. How's it going, everyone? We're ready to do some flood fill algorithm stuff today, I think. Let me pause the music. Loop. And bring up the project. So we're going to be re-implementing our flood fill algorithm in C#, which should be pretty straightforward. Yesterday was pretty good. We settled on a visibility method, like a cutaway system that I'm pretty happy with. It raises some interesting questions about like how big the game world should actually be, like how big a given ship should be. And like currently we're just looking at something like this as like the maximum boundaries. Obviously this is like not what we'd actually do. But we're looking at something like this. Two nerdy nerds raiding with a party of 44. Oh my god. Nerds. I was lurking a little while ago. I was lurking in the channel. Checking out your jam game, Backhand Bandit. How does that going? How do you feel about that so far?
He's dead, Jim.
Hello, nerds. Welcome in. We're looking at, oh, he is dead, Jim. Thanks, Foul G. Average Goob, you're doing that too, aren't you? Well, I say two-person. Is it a three-person jam team? Is it the two nerdy nerds and the Average Goob? Feeling good? It's coming along? That's awesome. That's awesome. Y'all picked a hilarious time to pop in just as I'm staring at this, like, gray cube. We're, like, working on the next version of our auto tiler tool. This one's, like, hooked into our ECS backend. That's awesome. I'm very excited to see how that ends up. I want to finish this wall. So we implemented a new visibility cutaway system yesterday that, like, it used to be every time you drop down a layer, it would just shave off the entire layer above it. But now we're kind of doing this, like, tiered cutaway thing where it peels back the ceilings above you. And we set this up yesterday. I'm, like, reasonably happy with this. So this is kind of what we settled on yesterday. We tried a bunch of different ways of doing it, like a bunch of complicated ways with like spheres and cones and slopes and all these things. And then we just ended up with this, which is like really simple. Still looks like wizardry to you. New favorite streamer? Such Trek, much star. Yeah, thank you, Foul G. Very Star Trek. You can't really see it from the cube, but this is supposed to be a series of like decks of a spaceship. So I can kind of get out of this. And like this is kind of the vibe we're going for. We're going for like a FTL kind of style game in like isometric 3D. That's really simple. It is compared to what we tried yesterday, Falgi. We tried a bunch of formulas where we were trying to get like curves and like carving 3D objects out of it. And like we tried a bunch of different stuff. And I think we're pretty happy with a relatively simple system in what's a pretty simple test case. So this is kind of the style, the vibe we're going to go for. So you kind of saw the stacked layers. So you're going to have like multiple decks of your ship. It's not going to be like top-down 2D like FTL. We're taking a lot of inspiration from like Into the Breach. So it's probably going to be like it's kind of a mashup of Subset Games, 2 games. It's like FTL and by way of Into the Breach. So it'll probably be turn-based. It's got our kind of pseudo-isometric look to it. Very, very Star Trek. As Foul G noticed. Thank you, Mr. Magoo. Appreciate that. Anyone else who's popped in and said hi that I haven't gotten to? Distron. Temptic. Hey again, Temptic. Masette. Thank you all. Thank you all for popping in and hanging out here. Hey, Scott Hopkins. Happy Saturday. Does it make a difference for you whether we watch on YouTube or Twitch? Whatever makes you happy. Whatever you like. Penguin Ye 9, thank you for the follow. Oh, and Mr. Magoo, thank you also for the follow. Immediately followed as soon as they hopped in. Didn't even wait for me to prove myself here. So we're doing one other thing to kind of bridge the gap between our old version of the auto tiler and our new version. Our old version of the auto tiler is like this. It's like very, very simple by comparison. Actually, it has a couple extra tricks that we haven't gotten yet. Like we can like lay out a room with just a single click drag. But it has this. It has like a compartmentalization system, so you can see the color change when we seal up the room. So when we seal up the room can tell that it's pressurized now from like the outside world. And we're doing that with like a simple flood fill algorithm. So we need to re-implement that in our new system. But we have some other stuff that we need to implement, like door support, like support for one or more doors. We haven't added doors yet to the new editor, so we need to do that. I definitely prefer the new visualization system. This one's clean because we just shear off the whole level above it, but I feel like it gives you less of a sense of where you are in space than the new one. So that's kind of what we're working on today. Beam us up, Scotty. You got it, Foul G. Let me beam you up. Welcome aboard. Tuner Nerds, awesome stuff. How's the new logic layer coming along? It is logic. It is, if I may say so myself.
Logic was impeccable, Captain.
That's how I feel about it. It's pretty good. It's an entity component system that we've written. Very bare bones. But it can do things like it has support for like buffers, data buffers. So we basically just have a data buffer associated with the ship, and we're just writing to it in our tool system, and we're doing all of the auto tiling on the C# side. And then we're basically packing it all into a byte array and sending it over to Godot, and it's just unpacked and plugged into the tile map data. So we moved the whole auto tiler over here as well, and it's a lot better as well, I think. And we're paying from very minimal marshalling costs. We're actually paying no marshalling costs by just packing the data here as a simple byte array and then just shoving it. We just pin it and send it back to the GDScript side. So kind of cool. You got to be careful when you're moving stuff back and forth from the managed and unmanaged worlds. So we're kind of trying to have a minimal touching between the two. So let's look at our auto tiling system here, or not our auto tiling, our flood fill algorithm. So our flood fill algorithm is pretty simple. Sounds simple. It is to me. Or I should say it is compared to what we did before. That's kind of our principle going forward, is like do things as simply and stupidly as possible. We're like going for like the caveman solutions for everything. So we changed like the way we do our like some of our tile map stuff. We used to roll this up into like one loop, and then we would figure out what layer we were talking about, and we would assign all these variables and like do these math operations to figure out, okay, we're on the first layer, we do this. We're on this other layer, we do this. Now we've just unrolled the loop. So now we just do each loop separately. And it's like, it involves like some repetition of code and stuff, but it's really helping me tell where the domains are, like where responsibility begins and ends for things, rather than just having all of these tile map layers in a single for loop and then having to figure out what loop we're dealing with and having all these crazy nested conditionals. Now we can move the conditionals out to only where they're needed. Like, we are trying to be simple. It may not sound simple because I'm explaining it without providing any of the context for how we made the decisions, but yeah, so what we need to copy over today is this function, partition ship space, which this is the function that tests every block of the ship and basically assigns it as either being outside or in one of a number of rooms. And it's pretty easy to determine that because you basically you just pick a starting point that you know is outside, and then you iterate through all of the other spaces. And the way the flood fill works, if you encounter a closed compartment, you won't reach it in that iteration. So we put everything in the first, everything outside ends up in the first array, or the first, the first index of our array of arrays here. And then we do that again, but we pick an untested tile that we didn't reach before, which is in another room, and we figure out all the tiles in that room, and then we do it again and again. And we end up with this array of all of the rooms of the ship. And it makes it really easy to do stuff like handling explosive decompression or like transferring oxygen from one room to another. Like all the fun stuff that an FTL-like style game is going to need to have. Anyway, I'm going to dig into this. Thank you again, Two Nerdy Nerds, for the raid. I know it's late, so if you need to run. Or if you need to keep jamming. Good luck. Good luck to you and the average goob. I only saw like a few minutes of gameplay from Backhand Bandit, but it looks awesome. It looks like it's going to be awesome. I see you can't seem to get away from mines. You've got mines on the mind right now. All right, so the second function is the actual flood fill, and the actual flood fill is like it's kind of like what we described as far as doing the simplest thing. Like we just work through the stack and we evaluate for each neighbor. Each neighbor has a specific test of whether it should be included or I don't know what the right word is. Yeah, it's just a simple test. We're going to try really hard to implement this exactly as it's written here because I implemented the auto tiler not exactly as it was written, and we ended up debugging it for days, for literal days. So I'm going to try really hard to just basically copy and paste this code. There might be some data types that make this difficult. So far, I don't see any, but if we run into some, it's possible we run into some ugly things I don't want to do. But so far, this looks very compatible with our current way we're holding all the data. There is one problem here that I'm realizing. Mr. Magoo, 10 hours of modding for your friend is a bit much. You love this stream? Thank you. Thank you, Mr. Magoo. All right, so the problem I see at first is that in the old way of doing things, we had a separate ship volume, which was like a larger bounding box, and then we had a slightly smaller buildable area, and that's so we could get around everything. We could search around the edges of the ship and make sure we didn't miss anything, like we didn't miss any avenues into it. We don't currently have that set up, so we need to define that. And the issue of that is that we aren't currently storing that amount of data. How do I want to deal with that? The easiest way would be to just change the bounding area a bit. Yeah, we need to add some distinction between the volume of the ship. Well, maybe the easier way to do it is actually to have a different search pattern the first time around. Penguin Yee, first time watching live. Really looking forward to the project. Thank you so much. This is a long project. We're about a year into it, approximately. We actually started streaming this project, I think, in February of last year, beginning of February. So we're actually very close to like the 1 year stream anniversary of this project. We've done a lot of exploration, so that means we've done a lot of work that we had to throw away, and we continue to do that. So that's kind of just the way. Let's make a separate system here. I'm just going to currently call it the fill system. I need to come up with longer names, but right now all the systems have 4-letter names, and I kind of want to continue that for a moment. I'll have to start distinguishing them more, but for now I do not. And so our systems are very thin, and they actually don't implement an interface or anything like that, even though they probably should. They really just implement they might implement a ready function. They usually implement a run function, and they just do the thing. And I like having thin systems that have very few responsibilities, but it's kind of nice when you have a big system like this. Like this system just handles all of the auto tiling, rather than, I considered splitting up each layer of the auto tiler into its own entity and processing them separately, but then we don't get some nice things. Like if we process them all at once, we can store everything in just a couple of dictionaries on the system, and it simplifies our search, our processes later on for like. So I don't know. I'm kind of going back and forth. I think the first time you build a system, it should be a big monolith system like this, and then what you do is, if you identify areas where you can split it off, then you do that. You don't start that way, but you do it eventually. When are we going to run the fill system? The fill system should probably run after the tool system, but before the tile system. Because the tool system will change the... it'll change the layout of the tile blocks. And if that happens, we need to test things. These are not in alphabetical order, and that kind of upsets me. Time for some foods. You got this. Thank you. Thank you, Turner Nerds. Appreciate that. Thank you, Raiders, for coming in and hanging out for a bit. We're just getting started for the day. Kind of impeccable timing, if I may say. I'm hoping I can tune in and watch a little bit more of your jamming tomorrow. If you're going to be jamming tomorrow. It's very early for me when you start that. Let's just throw it in somewhere. This is pretty ugly, and I'm actually I'm noticing we're gonna need to do some kind of threading soon. Not like an immense amount of threading, but like if this is a turn-based game, we don't need to run the whole system of systems on a given frame. I mean, it'd be nice if we could, but I'm starting to consider kind of unlocking the maximum build area of this game. Like right now, we're limited to these 15 by 15 buildable grids. And that, I feel like that's coming from a good place. It's coming from like an idea of like Into the Breach or FTL. You want to be able to see the whole game board at once. But the problem is, because of the way this is stacked, that's never going to be possible. Like, you're never going to be able to see the whole game board. Like, you just won't, because there are layers on top of layers here. And so, I don't know. I think we're going to set it up like this to start. But I feel like eventually we're going to want to unlock this and just have bigger ships. And the problem is, from my experiments, if we make the volume much larger than this, excuse me, we start to see some latency when we try to process things like a flood fill. If we're flood filling all the time and running the auto tiler all the time, like right now it's like instantaneous, like there's no issue. Because we're recalculating the whole tile map every single frame from scratch. Like we're not just considering the diffs and stuff, we're like reevaluating the whole thing. which is inefficient. So we probably want to go in one of two directions. We probably want to start limiting either the amount of stuff that we need to update on a frame or spooling it off into a thread so it can just do its thing, and when it's done, it's done. I'm kind of hesitant to do that too early. I think we're gonna just stick with this small buildable area for now. Both because like a starter ship, you probably wouldn't want a starter ship to be bigger than this anyway. If like late game you can get ships that are big enough that you have to like scroll around to like see the whole ship, that would be cool. But I think to start, of a total buildable volume of this area is like already plenty. What we do need to do though is I need to add a distinction between the buildable area and the total area being stored. Or like I said, I just need to test differently, because right now we add this buffer where we could store block data, but the whole point of this is like we don't want any block data to be in this boundary where we can test from. Maybe when we're doing the initial pass of the flood fill, we just test the outer area. We test all the points along the edges of the volume. And if we can find a way in, we continue testing. We like continue to pursue it. But if we can't, we just carry on. That might be the way. Because then we don't have to increase, because right now the buffer is like that whole 15 by 15 by 5 area. And that's a lot of tiles. And I don't see the point of storing like a 17 by 17 by 7 volume if we explicitly are never going to put anything in the outer rows and columns. Like if we're very particularly not, and we're just including it for the sake of the search pattern, then we should just change our search pattern instead of storing all that extra data. Although, I don't know, there's an argument to be made otherwise, which is that you want, like, let's say someone does a spacewalk. If someone's doing like a spacewalk, you'd want them to be able to like be on those outer areas where you couldn't build the ship, but like someone could walk along. Captain Anosa, raid. You're a little late. No worries, Captain. Welcome aboard. We're working on our isometric FTL-like. And we're working on a flood fill algorithm, and I'm kind of deciding on the best way I want to adapt our current flood fill algorithm to our new tile editor. Better late than never. Yeah, no worries. I like to see people trickle in. All the people that lurk, that kind of, you know, leave this on a background tab or something, and then they come by like 10 minutes later, 15 minutes later, and they're like, these aren't my nerds. This is a different nerd. This is a Star Trek nerd you're dealing with now. So if I was to do a different flood fill search, so our current flood fill search, let's just go through this just to remember how this works. We set an initial tile, and we set the index. So the partition index is like the current partition we're searching from, because each time we run this, we're basically figuring out what a different room is or compartment. And so we have like a fill array. The fill is all of the fill is all of the tiles that were actually, or all of the blocks that we consider to be part of this compartment or partition. The flood is all of the blocks that we've tested. So a block could be tested and fail and not be included in the fill. And then the stack is just our working memory that starts from the initial tile. This will have to be a list. Actually, these will all have to be lists in C#. Captain, you raided into Trinity Co., who raided into Two Nerdy Nerds, who raided into me. You're just along for the deluge now. Thanks. Thanks for coming along for the ride. I appreciate that. I appreciate a Twitch viewer who's kind of just vibing. I do that too sometimes during my when I'm doing like working my day job. Pick someone in the morning like Fool Box or Sorcery or something like that, and then they'll raid into someone who will raid into someone who will raid into someone. Yeah, it's fun. It's kind of fun to go on those Twitch rides sometimes if you're busy doing something in the backgrounds. I question my indexing methodology here. Oh, I guess because this is GD script and they want you to double index if you're talking about a line continuation or something. So we're just going to read through this logic just so I remember how this works, because I honestly don't remember how this works, and I feel like this is the least efficient flood fill algorithm. Like, I think we implemented just the most basic, simplest one where we test all the 6 adjacent neighbors. We don't test diagonals, which I think could get us into trouble at some point, but probably won't. Foolbox is like always streaming in the morning. It's perfect. Yeah, you can almost always start with Foolbox and go on a ride from there. Some people never stop streaming. Like sometimes I'll start watching Practical NPC in the morning, and it'll be like the middle of the afternoon, and I'm like still watching Practical NPC, and I'm like, Jesus, take a break. I don't think I could do a stream more than 4 hours long. Like, right, my typical streams now are about 3.5, but I stand for the whole stream, so I don't know if I could go longer than that. Practical NPC is built different, truly. It's fun to watch though. Practical's been doing a lot of auto tiling stuff too, but like doing like the more. I think they have kind of their own system for it, but it leans more on like terrain sets and stuff, so it's more integrated with the Godot's built-in auto tiling. So I enjoy watching it. I enjoy seeing how that works, because our auto tiling system is 100% custom, because isometric auto tiling is like kind of hard. Our auto tiler can take an arbitrary number of tile map layer inputs. Right now, I think it's comparing about 7 different layers to come up with its results. But that's like just that's only because we've implemented that number. Dude will wake up, brush their teeth on stream, and just work all day. Yeah. Yeah, couldn't be me. I mean, partly because I have like a day job, but even if I didn't have a day job, I think I would have to do like 4 hours of work on stream and like 4 hours of work off stream or something like that. That'd be the joke, that I'd only work 8 hours if I was full-time game dev. I would definitely work more like 10 to 12. Which I already do because I'm balancing this with a day job. But that's kind of partly why I stream on Saturdays. I like to see people that I wouldn't normally get to see. I like to see some people stop by who aren't normally able to tune in because of the work week or time zones or whatever. Falg, if you may, what kind of day job do I have? Yeah, you may. I do like HR backend stuff, so like HR information system, like backend stuff. So a lot of my day job involves both, dealing with typical HR stuff, like compliance things, but also a lot of what I get to do is automate. So I get to do a lot of systems programming, like automation and stuff, because we have a very small team that handles a pretty large company, and I'm like the only HR backend person who's like day to day doing it. So the more I can automate, the happier everyone is. So I get to do some fun stuff. I get to do some fun programming, but it's not like game dev. Nothing like game dev. For one thing, it's mostly JavaScript. You do databases, not like strict database programming. It's more hacked together than that. Captain, you were building an isometric game using the built-in tools. You're curious what's different about it in your custom tools. So I don't know when you were doing it. Let's look at it a little bit. So I don't know when you were doing, if you were doing isometric pre 4.3, because before 4.3, they had, you know, tile maps, not tile map layers. And tile maps themselves had huge problems because if you tried to do scene collections and stuff, you'd get all this z-index fighting and you get some crazy stuff happening. Tile map layers are better. It was in 4.3? Okay, so you were doing tile map layer. So the way our system works is like, here's our block volume up here in the scene. So this is like the full 3D volume of the ship. And then these are like container nodes that are for each area. So for each 2D layer. Homesick Alien Zero, thank you for the follow. So each of these areas has, right now it has 6 layers, but that's because I haven't re-implemented the doors. The doors would be a 7th layer and they'd be scene collections. They wouldn't be. So what I'm doing here is I've actually split out the cube into 3 different layers and the bulk, well, 6 different layers. So we have floor blocks and we have an X face, a Y face, and a Z face. And for bulk layers, we have an X face and a Y face and a Z face. So I think if your tile was an entire block, like a whole cube, I think you could probably get away with using the built-in tools. But we're trying to do something that's a little crazier, which is like, oh, it was right there. This. We are manipulating the outlines based on the neighboring faces. So you can kind of see, like, if you get this neighbor, then we remove this outline. If you get this neighbor, we remove this outline, and such and such and such. So the combinatorics of this, if you were doing it per block, is this. These are all the different possible combinations. For a single tile color, like this is presuming that all 3 faces are the same color, which in our basic test case, all 3 colors or the 3 faces might actually have different colors to them. Like we might, like so far we have this, we have like a dark gray, a mid gray, and a light gray. So imagine the last poster I showed you, and imagine one of those for each of these squares. And that's just what we have so far. Like with just a dark color for a middle hull, a light color for an inner hull, and a medium color for an outer hull. So I decided to split that up per face, and it means that we're rendering each face individually. So we have like a set for the floors, for the top faces, we have a set for the side faces, and we have a set for the side floors. And each of these are on a different tile map layer, so we're cross-referencing many tile map layers. And all of that achieves for us this sort of effect of, you know, we can drag these out and it handles the outlining for us. It handles the, so you can see the dark color. You can see the dark colors for the middle hulls because it calculates what the hull is first, and then it does the auto tiling. So it knows like whether blocks are up against other blocks, in which case it uses this dark color. And we send all of that information to the tile map so that we can do this cutaway system. And right now we're not using the light and the dark, but once we get that flood fill, we'll also have that where these outer shells will be all mid-tone gray and the inner shell will be light gray because it'll know that this is a sealed compartment. So yeah, I just needed a new system to handle like an arbitrary number of comparisons. And that's kind of what we're doing. So yeah, I think for a typical, like if you were to do Final Fantasy Tactics or something like that, I bet you could probably do it with the built-in isometric auto tiler. But we're doing kind of a strange beast that I haven't seen a lot of, you know, examples for. Kind of having to figure it out on my own. Yeah, it's far beyond what the built-in tools could do. Yeah, thank you. Some folks wonder why games take years to make. I know. We've spent a year on this, and all we've done is really decide the direction that we're going with the back-end tools. Like, and some other stuff. But like we've experimented with all different ways of doing this. Like I showed earlier, the previous auto tiler, which just still works. I've managed to keep it compatible with like as much of this as possible. And now we have a new one that uses a completely different back end because it uses our original one just stored everything directly in the tile map, whereas this one has everything in an entity component system buffer, or it has it in an entity buffer, so it's like being stored separately. There is one other feature of the old tile map editor that we haven't implemented yet that we really need to, which is the ability to rotate. So like we really need to get something like this going where I could lay out a room like this. Go down. Let's build this. Go back up, maybe add no. Put this here. Get rid of the floor, the walls here. Go down a layer. Now we can add another one. Go back up here, add some doors. Make a little airlock, I guess. This is the demo I always do. It's kind of a good test case of this system. So we could do all of this. And then we can turn it. So we can reproject the tile data from a new viewpoint. The new tile editor can't do this yet, and like that's probably the next thing we need to do. And this is not easy either. I asked a game developer who does this, who has a game that can achieve this, how they did it. And you know what they told me? They're doing it in Godot too. This is what they told me. They render all 4 of these views, and they just switch to whichever one the player is currently on. So they re-render the whole game 4 times and keep track of objects in 4 different locations. So everything is mirrored 4 times, and they just switch to whatever view they want. For us, we're not doing that. We have the game data is in the one canonical view, which I guess is this view. And then if we want a new view, it just sends it to the tile map reprojected for that view. And, you know, we recalculate things like all the, you know, the face data and everything on demand. And right now it's super fast and responsive. It might not, you know, continue to be so, especially if we increase the ship area. But it works for now. All right. Scott, that's a super interesting answer. You wouldn't have even thought of that. Yeah, it was the most straightforward way to solve it. Yeah, just 4 different renders and you just switch to the one that you need. I mean, for an isometric 2D game, it's not usually so demanding that that's a problem, but it was not the solution I wanted, which is partly why we built a separate simulation layer, because I didn't want like a scene tree that was just full of all these different things. I want the scene tree for us to be like pretty simple, pretty bare bones. It's just stuff that needs to be rendered immediately and stuff that needs to be interacted with. And everything else is going to stay in simulation land. All right, so let's set it up for this. So we still need to look at our flood fill. Distron, you wonder if anyone who worked on isometric games back in the DOS days might have some advice on how to program this kind of stuff. I'm sure they do. And I'm sure it's tailored to like the old hardware that was very 2D tile specific before like the advent of like 3D accelerators and stuff like that. I've studied a little bit about old isometric games. And it was definitely a certain time in terms of hardware capability that necessitated a lot of work. Now we're just doing it for aesthetic purposes, right? Like game would be probably easier to do in 3D. But you know, it wouldn't be the same. And I probably couldn't do quite the same level of cool cutaway stuff that I'm doing. But yeah, there's probably more to be learned from that era for sure. But you know, everything needs to be relearned by each generation. It would be kind of incredible if each generation could actually learn from the generation before it. That would be an improvement. So, all right, we define our fill array, which is what we're returning at the end. We're defining the flood array, which is where we're searching. Like these are the searched tiles or blocks or whatever you want to call it. The stack is our working memory. So as long as the stack isn't empty, we grab the tile, which is just the top of the stack. We add to the tested tiles this tile because we're now testing it. If the tile blocks, so if our block thing has this tile, so this is the thing I need to work around because this is going to return false for us now, always, when we're searching around the outside of the ship, and I need to come up with something different. I almost need to, when I do this initially, the initial tile maybe needs to be an array, and I just populate it with all of the outside tile things, and we just guarantee that we search all of them. That's probably what I'm going to do. Probably. Because I would rather not just store empty block data if I can avoid it. So if tile blocks tile, and so what we're asking here, we're basically saying, is this a wall? Is this block a wall or a door? If it is, we end the search because we don't test through walls and doors because walls and doors are the edges of, they're boundaries. So then we fill. We put this in the fill if it's not already there. Then for calculating the next one, now we're calculating the neighbors. Distron, you're pretty sure new generations can learn from previous generations. Otherwise, we would never have advanced out of this Stone Age. Not sure why game dev seems to keep forgetting its history. Kind of everyone keeps forgetting their history, but I mean, yeah, obviously I was being a little pithy because we obviously learned from previous generations, or you know, I wouldn't be here streaming to you from a computer around the world here. But it just feels like, you know,
Logic
many
was
lessons are
impeccable,
forgotten.
Captain.
Impeccable logic. Thank you. So we calculate our 6 adjacent neighbors here. So we do.
Illogical.
What a contradiction. Hey, Dom Noble Hero. So we get the negative Z tile. We test to make sure it's within the search space. We kind of need to do that for all of these. If it is, then we advance the tile in that direction. And if not, tile blocks.has tile. What? Oh, so we're saying if this tile is empty and we haven't searched it, let's search it. That's an interesting phrasing, though. Oh, that's because we're going up and down on the z-axis. Right. Okay. That's a special check for just the z-axis. And then for the xy axis, we just check to see if this has been tested or not. I could roll this up into something, but I'm not going to. I'm just going to do it like this. And then we say the block partitions of the partition index is the fill. And then we return the flood because we want to pick, next time we run this function, we want to pick a tile that hasn't been searched from. Yeah, okay. I think I have a thought process for this. Okay, and so we got to this function from this function, the partition ship space, to which we pass in an array of all of the vector 3i's. We don't need to do that now. We could just submit a bounding volume because we have those instead in C# here that we've made for us. We set an initial tile. So this we probably, in the future, we want this to be like an array. Or we could send another bounding volume that we constrain in a certain way. Tested tiles. So while not untested tiles is empty, tested tiles is the result from the flood fill. And then for every tile in untested tiles, we try to remove all of the tiles we have tested. Or for every tile in tested tiles, we remove that from the list of untested tiles. If the untested tiles array is now empty, we stop, we're done. We pick a random untested tile. And we do this again. If tile blocks has the initial tile, okay, so we eliminate tiles. Okay, so we say while tile blocks init tile, and so while the initial tile is a wall or a door, so we don't want to start our search from a wall or a door because those are solid objects. And we don't want to start our search from there. We want to start our search from either an empty object or an object that's just a floor plate. We remove these options. If it's empty, we're done. Otherwise, we pick another tile and do that again. Partition count plus equals 1. We have a little check down here to prevent crashes in case we detect an infinite loop, which has occurred. Okay, I think I can write this. And by write, I mean rewrite. Distron, you're going to head off. Have a good one. Thank you, Distron. Thanks for hanging out. Hope to see you again. Have a great weekend. All right, maybe we write the flood fill first. And then we write the controlling logic second. So private, what are we going to return? We're going to return a list of vector 3's. Yeah, I think I'm going to have one version of this function that takes an AABB and one version of the function that takes a vector 3. So let's say initial init position, initial position, and then part index. Oh, int part index. We need to import some missing references. So we need the list, vector 3, flood. We'll say filled blocks. We can say partitioned blocks. And then we can have another vector 3i, and this can be searched blocks. Say compartment. And then we need a stack. We have filled, flooded, and stacked. It's kind of silly, but it's kind of what we did before. We'll change it later. And then the autocomplete was like, do you also want a list named blocked blocks? I'm like, no. I'll tell you what I want. All right, so while the stack is not empty, so while stack blocks dot count is greater than 0. Wow, it's like you know everything. Okay, let's at the bottom we say return flooded blocks. We also need to store in the system. Actually, no, we don't need to store anything in the system. Not yet. So we pick a block off the top of the stack. So list doesn't have the same nice pop back, pop front, whatever. Is there a stack? Oh, there's a stack. We just have a stack. Okay, sick. I've never used that before. No, I wanted to look at this in Microsoft Docs here. Never actually used the C# systems generic stack. Just an I collection. Push, pop, and peek. Okay, fun. We can copy it to an array at the end. Ooh, it's kind of nice. Oh, creates a copy of the stack. Oh, this is just their example. I don't care about their example. Stack is implemented as an array. Interesting. So I assume it's just recreating it's just doubling the size of the array whenever we need to. It's a little, I mean, that's not any different than probably how list works under the hood. Push is an O1 operation if count is less than the capacity of the stack. The capacity needs to be increased to accommodate the new element. Push becomes an ON operation. Pop is an O1 operation. Yeah, that's about what we were going to get. Unless we know exactly the number of things we're dealing with and we can pre-allocate the capacity, this is fine. I like this. Let's use stack. Stack. Say variable. Yep. Vector 3i towards. So tile is the pop, okay, and then flood. So we immediately add flood to the list, right? No, not filled, flooded. Yep. I wonder if it's doing a decent job of guessing because I wrote that this is a flood fill function. I'm curious about how their little auto thing works. So we ask if this has tile. So we're doing a test here. We're asking, does this block exist? Actually, we're doing is we're gonna ask if this block is a wall or a door. That's all we're gonna do. And if it is, we'll continue. So we'll say, oh, I need to actually get the buffer from this part index. Let's call this span or read-only span. Read-only span blocks. We got ads right now. So we'll pass in the span. Block span. I don't know, maybe just blocks. This is the capacity. What if how do I initialize this with just the value that I want? Constructors. So it doesn't have. Oh, well, this will be useful for. Okay, so I'm just gonna have to add. Just do this. Stacked blocks dot push initial position. It's fine. So we're gonna ask if blocks. We need to iterate through. Oh no, we say blocks. Oh, we also need to pass in the buffer then. Block buffer, read only span, blocks, buffer. I don't think I want to marshal the span every time. I want to pass them both in. Although maybe I don't care. So we'd say buffer dot get position, get index coords. Excuse me. Yeah. Dot has any block dot forms dot bulk or block dot forms dot door. Continue. Continue. Why don't you want to do a continue for me? Oh, I don't have enough parentheses. Okay, there we go. So yeah, so if this is a wall or a door, we just continue. We don't start a search from within there. We shouldn't need this check, but we're gonna have it anyway. This is probably like unnecessary because I think we're preventing. Well, we need it for the initial flood fill, the initial version of the flood fill that takes a buffer, or not a buffer, an AABB instead of a single position. Hey, Ryson, how's it going? Happy Saturday. How are you doing? We're working on our flood fill system here. Yeah, I don't think that check is strictly necessary in this version because we already pre-screen positions to not be these. So I think I can actually, I'm just going to comment it out for now because we're going to want to add this to the other version of this, the other variant. Actually, I guess are we not doing that check here? No, we're just adding stuff. Okay, so actually we do need to do this check because we might add a block to search. So if we don't continue, if so now we check if fill or if filled blocks dot contains coords. Do we continue? No. We say if it doesn't contain it, add it. Filled blocks dot add coords. Would I be better off making this like a just like a hash set? I don't know. Probably not. Because we're doing a search. I guess in this case it doesn't matter. It's such a small amount, it probably doesn't matter. Small number, such a small number of blocks comparatively. Probably doesn't matter. I know it's like minutely cheaper to do searches on hash sets compared to lists. And that minuteness, like, you know, adds up over time. Hash set dot. Oh, visited is a good word for it. I call this the compartment. It's going well. Good. That's good to hear. Visited dot contains. Yeah, this is like a simpler check. So maybe we just do that. And then can I say visited dot to array? Oh, we don't have a, oh, we only have a link way of doing that. Oh, well, I don't think I want to do that then. So visited, then the compartment. So if this compartment contains this, add it, return the compartment, return this compartment dot, copies it. Do I want to pass this back as a span? Probably faster, because we're going to need to iterate over it. All right, so if it's not a wall or a door, and if it doesn't contain, and if it's not already compartmentalized, we just add it. Lists don't have a triad, do they? No, of course they don't. Only a hash set might, or a dictionary probably would. Visited. Okay. Oh, actually we don't return compartment, we return visited. We set what we do for we're gonna set like a, oh, this is a little weird. This is a little awkward. I guess we don't strictly need to return the list of visited tiles or visited blocks. We could just return the compartment. It simplifies the work if we return the list of visited tiles, so we only visit every tile once. Then we need to set the compartment data, send the compartment data back separately. That's fine, we can do that. The way we do that here is we just set like we just add it to what are we adding it to? Or is this a dictionary or is this like an array? It's probably a fucking dictionary. Knowing GDScript, knowing the way I use GDScript. Yeah, it is. It's a dictionary of arrays, and what, the index of the dictionary is an index? Oh, that's so stupid. We'll probably just do a list of arrays or something that's equally stupid. Probably want to do that differently. I guess we could have out variables. Instead of returning something. Yeah, we'll probably do something like that. Let's get through the rest of this first. I'd rather do that than set like a variable of the system. Because we're going to eventually be flood filling like more than one ship at a time. And we'll actually need to set that partition data somehow. Probably set it to each block. Actually, we are going through the block buffer. Should we just be doing that? Instead of sending this information back, should we just be... That way we only need to return visited, and we could actually be setting the compartment data. We actually don't need to store it then. We could actually instead just say... Instead of doing this, we could say buffer... Well, hold on. We could say buffer... Where'd I got index coords equals... Say block equals buffer dot get index coords. Actually, we shouldn't be getting this and then assigning it back. I mean, we could. It's a span, so we could just like operate all of it directly there. Doesn't really matter. could say this. Oh, we would need to do this after we get the chords, Godot. Oh, it would be blocks. Oh, this can't be a read-only span. This would need to just be a span. So this is our block, and we can ask if block has any. So if block has either of these forms, we just continue. Otherwise, we say we can get the index. We can say we can assign it back with I'm confusing myself because of how I've got this written here. I should probably just call this span. Because this is the block buffer and it actually has all of the information. Call this, we could say blocks. I added the span to this as a way of avoiding having to pass around the span and the component all the time. But I'm seeing that I kind of still need to do both if I don't want to just get the buffer back all constantly, which I don't really want to because it's like kind of expensive. I mean, it's not that expensive, but we are casting a byte to a type. It's like not free. So I'd rather not do it once per fill, especially if we're talking about the same one. So yeah, I guess we're gonna say this. We'll call this block. We'll call this like buffer, not data, buffer. Wrapper, I don't know. Buffer wrap, buffer span. We call this buffer comp. This is the component and this is the span. Thanks, Mr. Magoo. Really appreciate that. Have a great rest of your weekend. I'm persistent. Nothing else. That's the only thing I'll allow. All right, so the buffer span is going to be the block with a part of index, or no, of a part index. I don't know if I should do this thing, but this is kind of what I'm in the habit of from pulling things out of arrays and putting them back in. You like You assign a local variable the value, and then you modify it and assign it back. That's like what I'm used to doing, but maybe that's like not the way when you're dealing with spans. Probably doesn't harm much. Honestly, the compiler probably knows better than me about all this stuff, so. Okay, so we don't actually need to keep track of compartments.
Logic was impeccable, Captain.
Which is pretty great. We can actually just assign the compartment directly. We used to keep it in a separate, previously we would keep it in a separate impeccable logic. Thank you. So here we can say compartment, and we'll just assign it here. So this resolves the problem of needing to just send back a thing. Ryson, casting isn't typically that expensive. In most cases, it is just telling the language to allow the same binary data to be used as if it were that new type than transit data types anyway. No, you're right. It's probably not that bad. Basically, anytime we read a buffer or get component data, we do a casting. All of our component data is stored in byte form, and then we basically get the span and we convert it to whatever type we want. So this isn't free, Marshall.cast, but it's probably not that expensive. Yeah, the main thing is that because the sizes of the two types are different, the cast combines or splits values, which leads to a change in length. So really the only thing that changes is the length. And yeah, it probably doesn't matter that much under the hood. I'm a little worried if we end up running this on platforms that don't support it. But I don't think that's going to be a problem. When I was studying this, I was told this wasn't free. So I try not to do it constantly, but maybe it doesn't matter. Like if we're going to be referring to the same span in every call to the flood fill, I might as well just call it outside and pass the span in, rather than just passing the buffer component and then getting the span in each of these. But I don't know, maybe it doesn't matter. Maybe it doesn't matter. I'm kind of reaching the limit of my familiarity with kind of the .NET, the way .NET works under the hood. I'm also maybe getting concerned unnecessarily about this, but we do this all the time. Like this memory Marshall cast from byte to type, this is our bread and butter. This is like the foundation of our entire entity component system. Because we do this for buffers, but we also do this for components. So when you get a component array, you're basically calling into the version of that component type, the component type. You call the component type, and you're just calling read-only or read-write. And read-only and read-write are the same thing, where we cast from byte to whatever the type of the component is. So every time we get a chunk, we do this. So every time we call a chunk, we do the same thing. So I don't know, maybe it's like basically free. I should do some research. You're not all that familiar with C#. Yeah, it's a different world as far as like, or it becomes a crazy world when you start getting down into like the nitty gritty of how this managed stuff works. But span in memory is like super fast, so I don't think we're going to notice it. I don't think we're going to notice it very much. But there's probably no harm in just passing the span in and calling it outside. We need to pass the component around because the component has helper functions that let us like convert from a vector 3 to like the index and stuff like that. I guess we need to check to see if this is safe to do But we can check it when we add it to the stack. Or maybe we should check it. Yeah, let's check it when we add it to the stack, I guess. Okay, so we've cut out a nice little chunk of this by just setting the partition here directly. Oh, Mr. Magoo, thank you for the hydrate. I've literally only been drinking coffee this morning. And Mr. Magoo, I love Leslie Nielsen. I watched Police Squad over the Christmas holidays with my parents. I love watching that. Sorry, someone's texting me here. I mean, technically, it was the Naked Gun from the files of Police Squad, but you know, they're all equal in my eye, pretty much. Yeah, the Naked Gun is so good. To say nothing of Airplane. Your name makes me think of Leslie Nielsen, obviously. National treasure. Let's keep going. So we do all of this. Now we just need to define the next. Why do I define a variable here? Oh, because of, so flood, pushback. So wait, why are we adding it here if we're also adding it here? That's silly. Do this up here. So we'll pull the coords, we'll add it to the visited list. Then we'll grab the index in the block. And then now we'll figure out what we want to do next. So this is where we go through, we iterate through the 6 adjacent tiles. So if tile.z minus 1 is greater than or equal to the volume min.z, so then we just add. We could just say coords plus vector 3i dot forward. Oh, we don't want to do that here. So we want to say, we could just say if this is still within the bounds, then, and in this case, we want to make sure that we don't have a block. So we need to get the block. So in these two cases, in this case of the z's, let's go the other way. I'd like to start with the x and the y. So if we haven't tested it, so if it's within the bounds and we haven't tested it, add it to the stack. Okay. Oh, are we adding? We're probably adding this. We're probably adding it to the visited so that we don't fill the stack with the same tile many, many, many times. So like if it's pending in the stack, it might not also be in the visited list yet. And we don't want to visit a tile more than once. So let's actually move. Oh, is this why we have this here? We actually need to move this up here. We want to say visited dot add initial position. Oh, we could just initialize it with the initial position. Weird how we can't do that with the stack. So we can take that out. That helps. And then now we'll say something like if block. What are we checking against? Oh, we're checking to say if we visited coords plus vector 3 I dot left. Oh, we also need to check the boundaries. We need to say if bounds, no, if, what do we call this? Buffer comp contains coords plus vector 3i dot left. Oh, we'd say if it doesn't contain it, or we've already visited it, then we continue. And we just kind of go through, and if it's not, we'll say stack.push and visited.add. We'll just do the same thing a bunch more times. All right, we're doing it. Okay, here's where I could actually put a I could compress this down. But we're not going to do that because that's not our principle right now. Our principle right now is to make things simple and just keep that stuff unrolled. We can roll stuff up later. Okay, so that's that for all of the horizontal checks, the XY checks. We need to do this a little differently. You can do the first check. The first check is the same, which is buffercomp.contains. Oh, can you not guess what I want to do anymore? There we go. And now we need another if buffer. No, we need to say if buffer span buffer comp dot get index coords plus vector 3i dot forward dot has any block dot forms dot bulk or block dot door. And we continue. Now we do the same thing down here. There we go. Kind of interesting to see how much I need to write before the autofill works. All right, and that's our neighbors. That's adding our neighbors. So we have this extra check for block types here. What I should do is have like block.forms.solid. I should define that as a form, as a combination of bulk and door. And that way I can do any other checks. Let's do that. That actually sounds kind of good. Block.forms. So we could do solid. Solid is 2 and 4, so it would be 6. We no longer only have four letter word block types. Horrible. I should rename this empty instead of null. Now we have solid. So I should be able to just check if a block has any solid forms. Well, solid, I actually don't know if I want to, this isn't a type of block. I'm not going to put it in that list. And I'm not going to put both in here either. Although maybe I should actually. Both make sense. Solid doesn't make sense. Deck, bulk, both. Both is so ambiguous to put here, but whatever. All right, so this should be the simple flood fill check when we start from a position. Then we need a variant of this function that takes in a buffer, or not a buffer, a boundary, a bounds, an AABB. How do I do that? So I'm going to do that. Not how do I include it, but what else do I need to include in terms of, I guess let's scan this over real quick, make sure we didn't mess this up. So here we just say if we haven't visited this. Oh, is that all we check? Are we not boundary checking when we do this? Oh, the boundary check is here. No, I kind of don't want to do it that way. I kind of want to boundary check when we add them to the stack. Because if I don't, we're just gonna go ham. You could search endlessly. Why doesn't that end up happening actually? Why don't we end up accidentally doing that? Oh, we do it right here. We are doing a boundary check. I'm a fool. All right, so that's the flood fill where we take a position. Let's do the flood fill. Let's do a version of this where we take a boundary. And that's going to be our initial one. That's going to be the one for the initial compartment. And it's going to behave a little differently because it's going to need to search around the edges of the volume. So this is going to, so we don't need to include a compartment because it's going to just be 0. And instead, we want to include an AABB. And so this is like our volume. And then we need to do one other thing. I feel like I'm doing this in maybe the tool system or the tile system. I've at least added the ability to do this in the AABB where we can cut out an interior boundary so we could only process the edges of the AABB. So we could ask where's the AABB? Oh, it's down here. I need to organize these better. I have components that I've put in the entity component system namespace that shouldn't be. They're like math components or something. They're like my own math components. Which it's like, why did I do that? So instead, what we want to ask, so we could get non-overlapping, and we could define an AABB that's inside, that's like one smaller. It would just be like minimum plus one and maximum minus one, which would fail under specific circumstances, but I think that would be okay. It's interesting that we have a get non-overlapping that we use, but we don't use get overlapping. Where do we use this? In the tool system? Oh, yeah, yeah. So here we are. We send in like the bounds, and then we send in like the active, which I think is actually maybe the wrong way to say this, but it's kind of how I don't put enough intent with my parameters. Like here I just say coords, and it's like, yeah, but whose? Here it's like bounds, but it's like bounds and active, and like the active one is actually the one acting as the boundary. Like, I don't know. Again, we talked about this. Ryson brings it up as well too. It's like one of the hardest things about programming is, what was it? It was like naming things. What was the second one? It was like naming things, something else, and it was like, I don't remember what it was. Naming things, something else, and off by one errors. And that's funny. That's a good joke. That's a good programmer dad joke. I wish I knew it so I could I could have delivered it correctly. All right, so visited. We could actually do visited a little differently. Did I just say visited? Visited. Can I just add a collection to a stack? Can I do it like this? Yeah, okay. So I can make a new stack. Don't need to push. A visited thing is actually just going to be volume dot get non-overlapping, and then what we need to do is we need to pass in AABB interior. Actually, we don't need to pass this in. We could actually just say volume with, or we could actually just say new AABB volume dot minimum plus vector 3i dot 1 volume dot maximum plus vector. So we can just pass in a slightly smaller volume, which will work in all cases except if we pass in, a small enough volume. So we just need to be careful about that. Ryson, the two hardest in programming are naming things, cache invalidation, and off by one errors. There it is. Thank you. Thank you, Ryson. Saving the day. I'll try to remember that. So for this one, we can actually... So by adding all of these to the visited up front, we can save ourselves some trouble here. I should probably name these functions differently so that their different intent is communicated. We could call this like exterior flood fill. We could call this interior flood fill. Because the exterior one needs to work a certain way. Bryson, someone asked for a programmer dad joke. Someone asking for a programmer dad joke is like putting up the bat signal. Yeah. Well, thank you for answering. You're the hero we need. All right, this should work. I think I handled the different case by just doing it this way. We do want. Well, no, we're just handling this, aren't we? Wait, where are we adding this to? Oh, no, we don't need to. I'm a little concerned about this, but I think it's going to work. We could probably simplify this with just a loop through an array. And I said I didn't want to do that, but in this case, I might make an exception. Who cares? Who cares? Brett, you didn't even know Godot could move, much less go faster than light. Yeah, we're doing something. We're doing something. We're working on an FTL-like that's isometric 3D, so we're addressing some isometric 3D stuff. We have a tile map editor. This shouldn't crash, right? We have a tile map editor that has this big custom isometric auto tiler we wrote, and we're working on adding a flood fill algorithm to it so that we can tell where the compartments are, so we can do the fun FTL-like things of like explosive decompression. So yeah, here's like a simple volume, and we just need to be able to tell that these rooms are enclosed from the outside world. So that's what we're setting up tests for. Honestly, looks super cool. I appreciate that. People keep saying that even though it's just a blank concrete like slab that we can peer into. Although addressing the visibility issue is a core issue because you need to be able to peer into these levels. You love the extreme angle? Yeah, it's an unusual angle. It's dimetric, so it's like more side on than isometric. Isometric is like more top down than this. And I'm doing that because I didn't want to draw the characters from top down. So the characters are basically side on. You can kind of tell if you look at their chairs that their chairs are at this like, they're almost like at a pop-up book angle. and so are the characters. So I think it matches up okay. We'll see. We'll see in motion. I can animate some of these characters, but we aren't able to have them run around right now in the game because we're kind of rebuilding a lot of stuff. We kind of changed out our whole back end, and we're kind of rebuilding a lot of stuff from scratch. All right, now we need to move this function over. This is the function that controls the flood fill, that calls the flood fill. So we don't need to set an initial tile. Partition count can go up. So what did we call this? We called this like partition ship space. I'll just call this like partition volume. Or partition. Or maybe I just compartmentalize. Maybe we just call it compartmentalize. Because we have our exterior flood fill that goes from the outside in, and then once we finish that, we can run an arbitrary number of interior flood fills until we've determined all of the interior spaces. Private void compartmentalize. Int partition count. Interesting how it almost makes vertical space more readable than horizontal space, like optimal for skyscraper shapes. Yeah, it's kind of interesting like that. And that's why we're kind of going for this vertical stacked, like you have multiple ship decks that you're working, that you are, managing. Do we have a Steam link yet? No. We're still pretty early. These are like the tools that I'm using to like build the ships. We're still building the tools that we're going to use to make the game. But yeah, this is actually a new version of the visibility system we just added yesterday. This kind of 3D carve out thing. And I think it does really help. It lets you know how many levels down you are, which is really clever. Because I was struggling with that. I was like, how are you going to know what level you're on? But you kind of just know now. It's kind of snazzy. It works pretty well even if you add like a bunch of interior walls, which we're going to have. But yeah, I want to get a Steam page up this year because I want to start doing devlogs, but I don't feel like I can start doing like actual like video devlogs until I have a Steam page, like a call to action, somewhere for people to go after they've seen the video. So yeah, hopefully this year we'll get all that stuff out, and then we'll have enough systems complete where I can start doing like cool devlogs of stuff where I can be like, here's how the auto tiler works. Here's how, I don't know, whatever seems to be interesting to people. I think people like the auto tiler. Because the auto tiler is doing a lot for us. But yeah, addressing the visibility issues of this perspective is like really has been a major undertaking for this game. Because it would be very easy to make this game like impossible to see what's going on. Because you're so side on. An isometric block only blocks the one tile behind it, so you can kind of get away with it as long as everything is like about a block tall. You can usually see what's behind a block. Problem for us is that a block blocks the 3 tiles behind it, so it's like 3x the problem for us, which is why we've needed this kind of visibility system. But yeah, we have a long way to go with the tile thing. I have a bunch of new block types that I want to integrate soon. That's kind of the next thing I want to get to after this. Great work, sir. I don't know why you popped up in your algo. Hope you keep doing it. Subbed. Thank you, Brett. Appreciate that. I don't know why I keep popping up in people's algos, but I love it. But yeah, we have a bunch of new blocks I want to include. A bunch of angled blocks that we're going to get into the game. Because right now we can only currently support cube blocks. And it kind of, limits limits the kind of shapes we can make. So as soon as we're done getting this auto tiler or getting the tile editor back to kind of where it was before the rebuild of the backend systems, like this is the next undertaking for us. which is partly going to involve me coming up with a good way to turn this into a tile sheet, which I'm working on. The way that was recommended to me was doing something like this, where we define the faces. We draw everything as a 3D cube, and then we define which face belongs to what. And then we can just have a system that splices it up into tile sheets for us. That might work. That might work. We end up with kind of this facial. We end up with this split face thing. We also need to add a zoom system so we can zoom out, because we need a zoom out function where we can zoom out and see the at least the outside of the ship, if nothing else. But yeah, we got a lot planned. I appreciate you coming by and giving your support. Ryson, you heard YouTube recently changed their recommendation algo. There's actually more similarity to TikTok. That's super weird because these are like 3-hour dev streams. I don't know why they would recommend these to people, but Brett, probably works great if the closest quarter of the building is always gone, like a central shaft. Reminds you of the Way of Kings city from the third book. Oh, okay, interesting. Yeah, what you can't see here, but that is apparent in like our old version of the auto tiler, is that you can also just, oops, that was wrong, crash. Click the wrong button. We can also just rotate. We can rotate the entire thing around, so we could draw this shape out real quick. Oh, I keep doing this. I keep doing this the wrong way. So if we draw this shape out, then we go back up. Oh, that's the compartmentalizer working, by the way. We can rotate this around now. So we could just be like, bop, bop, bop. So with that, I feel like the visibility is not a big a problem, because if you want to look like way far back into the ship, you could just spin the ship around. So I don't know if people will use it that way, but the ships are at least going to turn around when you like tell it to turn around, and you'll have to deal with that. Even if people don't like actually doing that. It's going to happen. They're going to have to get used to it. Bryson, you don't mean in duration, but in pushing videos out to a wider variety of people? Ah, no, I think you're right about that. Brett, that's cool. You want to play it? I really appreciate that, Brett. I'm hoping to have like a prototype of like a one-on-one ship combat up. The dream is the end of the year. We'll see if we get there. We have a long way to go. But you know, we'll be working on this game for years. So like, I wish I could tell you could play it soon, but but I appreciate you hanging out. You can definitely follow along the progress here on YouTube. We also have a Discord. Like I said, once I get a Steam page up, I'm hoping to put out more like specific devlogs. But right now we're just growing the channel with just live dev streams 5 days a week, Tuesday through Saturday, around this time. Brett, remake Baldur's Gate 3 in this right quick. Yeah, it's an interesting, I think it's pretty unique because when people do isometric, they usually don't do a lot of verticality. Like, I actually am having a hard time finding examples of games that do isometric like me that also do vertical stuff, because we're stacking like decks. Yeah, thank you. Appreciate it. Have a great rest of your weekend. All right, so here's the compartmentalize function. This is going to mirror this function. So we need to define, we need to define an area to search. So we could say, we could pass in a list, but we actually want to kind of pass in an array. An array. We want to pass an array of vector 3i. I mean, I guess we could just pass in a whole volume, huh? AABB bounds. So we just compartmentalize these bounds here. We probably need to pass in a block buffer. The bounds and blocks. Oh, actually, we don't even need to pass in the bounds then. We can just pass in the buffer. That was your first thought after seeing the angle? Cool. Yeah, I'm really curious to see how the verticality works. I hope it works well. It's probably gonna be turn-based so that people can, so that we can say, you can say like next turn and it jumps the camera to whoever the next person, not next turn, but you can, like in Civ, you can click next unit. And so you could hit next unit and it will like take you to your next crew member. So you can like, so you don't have to be like super great at like navigating around the space. It'll just like take you, it'll like take your cursor to where that person is. So I'm hoping doing stuff like that, making it turn-based, having some tools to help you figure out where your crew is, makes it manageable. Part of me really wants everything to be on screen at all times. Like that's the joy of like FTL, Into the Breach. Even old games like Imperialism, they're like you want like as much of the action on one screen as possible, and I feel like we're violating that to a big extent. But maybe it'll be cool, or maybe it'll alienate people. We'll see. All right, so we need a volume to test. We could say array, or we could say vector 3i block volume equals. Actually, do we? Why are we having it this way? Why are we doing it this way? Oh, we don't want it to be a vector 3i or an array. We do want it to be a list because we're going to remove things. We're going to say list vector 3i, and we're going to say unvisited. Unvisited. Vector 3i unvisited is blocks dot to list. No, blocks dot AABB dot to list. Be to list or as list? I don't really know the difference. These are all creating a list and then sending it back. So I guess this is also creating a list. Oh, this is creating a list, adding the range of this whole thing, and then sending the list back. That's about as good as it's going to be. So we'll say to list. So the way this works is we would say while unvisited list. So we'll say while unvisited.count is greater than 0. So we go through, so we say tested tiles. We can say visited equals flood fill from, and then we pass through. So we do the initial set. What we want to do is the initial set. So we'll say, so we'll do one loop outside the while. We'll say list vector 3i visited equals exterior flood fill. We say blocks. Oh, we need to define the, we need to define the span. Let's see, span block. That doesn't work. Read write. How do I get the span? Get, how did I write this? Where's my block buffer at? Read write. Block buffer dot blocks. Okay, here we go. Block buffer. Block buffer dot read write. I'm gonna call this block comp. Well, we'll say block buffer here. Call this the block span. Maybe buffer span. I don't know. Say buffer. Buffer span. Here visited is going to be block buffer dot aabb dot to list. Then we exterior flood fill. We pass in block buffer dot. Oh, we actually don't need to do it this way. We could just pass in the buffer comp. We could define the volume. We could say AABB volume equals buffer comp dot AABB. We just pass in the block buffer and the buffer span. Cannot combine. Oh, we're gonna say span. Read only span. So now, so then after we do this, we're gonna say for each vector 3 IV and visited, for each coords, for each set of coords and visited, so unvisited is the AABB list. So we shouldn't need to do any safety checks here. We should be able to just say unvisited dot remove. We actually also know where these are, so I could actually say remove at, so we're not having to search the list for it. And we say block buffer dot get index coords. Will that work? No, that won't work because it's gonna be moving things around. So I guess we just eat it. We just say remove coords. So what if we fall into this while loop and unvisited count is already 0? What happens? Does the while loop evaluate its condition the first time? Or does it run once and then evaluate it? JavaScript makes me concerned about these sorts of things. The way like JavaScript handles this stuff. C#, does while evaluate its condition before it runs for the first time? When does the while loop check for its condition? It evaluates it before the first iteration and in between each subsequent iteration. Okay, cool. Cool. That's good. That's probably how it should be. So now that we're here, we're just going to keep doing this loop. But we're going to change it a little bit. We're going to say visited equals interior. Actually, what we're going to do is we're going to pull this down here. We're going to say partition count equals 1. Now we're going to pass in. So we need a test. We need an initial coords. I guess we can just pick a random one. I don't want to pick whichever one's at the back for some reason. Although when you remove when you do this remove in index of, so we do an index of check array.index of. Oh my god. Okay, there's a lot going on here. I just kind of wanted to know. I presume it searches from the first index and then goes. So maybe we should just take the last one so that when we remove it, it's easier. Or we could say unvisited.remove at 0. Does that not work? Does remove at not return a value? No, it's a void. Cool. Conflicting variable coords is defined below. Oh, I do define it below. You could just call it initial. So we'd say initial, we'd say partition, count, block buffer, and buffer span. So the only thing we need to do is we need to test the, well, we do want to unvisited remove at 0. We need to test what we want to use. So we do this test. So we say for each tile in tested tiles, if the untested tiles has this tile, we remove it. So here we do need to do a check. So we need to say if unvisited contains this. There's going to be a faster way to, we could say if not unvisited.contains, continue. Otherwise, remove it. There's got to be a better way to do this. We should probably do an index of and keep the index so we're not like doing this twice, this check for it. We're checking once to see if it's contained and checking again to remove it. Maybe this would be a better case of like using like a hash set. I don't know. Some other data structure. So what if index of doesn't return? What if we don't find the result of index of? Returns the zero-based index if found, otherwise -1. Okay, good. So integer index is unvisited dot index of. I mean, we could actually just go the other way of like testing. We could flip the test, but I don't know. So here we could just say if index is equal to -1, we continue. Otherwise, we remove at index. This way, we're at least not testing twice, or we're not, searching the unvisited list twice. It's probably better. We should probably do the same thing here. Move this up here. Mr. Magoo, 12 hours of moderating, still going. Wow. Hope you have a good night. Yeah, you as well, Mr. Magoo. Hope you get a break soon. Have a great weekend. It's been great to have you here today. Wait, I moved it. I just wanted to copy it. Here we're going to say if unvisited count is 0, we break. Or no, we don't necessarily say that here. We say that here. We could do that here. We could say if unvisited count is 0, we break. So we need to test the initial. We still need to test the initial coordinate. So we ask. So we don't need to pick random. We don't need to do this. We know it's within bounds. We do need to test it against the span. We would say while buffer span buffer block buffer dot get index. I call this buffer comp because that's what we're calling it elsewhere. The buffer comp dot get index initial dot has any block dot forms dot solid. So will this work? So has any goes through for each form and form if forms and form is equal to form, and has form. So if it's included here and included in the block, return true. Okay. I do love me these bit fields. They're making things pretty easy. What we should do is we need to swap this out with block.forms.solid. That kind of future-proofs it. So we can define blocks that are solid and should be interrupting. Although, shoot, that actually isn't true anymore, is it? We're gonna deal with that when we get there. I just realized that might actually, the way we're doing, because we've removed the requirement that you need to have, if you have a wall, you also have a floor. We've removed that requirement, and that is going to cause us some problems with this later. But we're just going to deal with them later. Not going to deal with them now. So while buffer span buffer comp.getIndex.has any solid forms. So then we're just going to redefine it. I'm going to say initial is unvisited 0. We need this unvisited count is equal to 0 thing. So if we run out of unvisited coordinates during any part of this, we basically need to check every time we do the remove at. So here's the problem. If we grab this initial tile and it's the last tile, then we hit this line and we just break out of the whole thing. But we need to test that tile. Problem is, if it's the last tile and this is true, we have a bit of a problem. We could say if unvisited tile count and this, we break. So if there's no more, if this is the last tile and it happens to be a solid block, we just stop. Otherwise, we go in here. We do this check twice in this case. So I don't love that. How did I do that here? We would set, so we would go through, set all the tiles. We'd pick an untested tile. We'd ask if the tile is in the block list. And then we'd go through this check. So I actually didn't do, so we'd check if it's empty here. We'd remove all of these. Then we'd check if it's empty again. I guess we don't need to do this remove at is what we don't need to do. Now, in which case we can just go into here. We actually need to reverse the order of this. We need to remove at and then get it. Well, we need to remove at, we need to check to see if it's empty. If unvisited.count is 0, we break. Oh, yeah, there's like a problem here. Why did I not run into this originally here? The untested tile, if we have no more untested tiles after we removed all of the visited tile or the tested tiles. Now I call it visited or unvisited, but here we call it tested and untested. So we remove all of that. We do that here. So we go through all of the visited tiles and we remove them from the unvisited if they're present. Set the partition count. Then as long as there are unvisited tiles left or unvisited blocks left, we pick an initial tile. Yeah. So we pick a tile. Here we're picking it at random, but now I'm just picking the first one from now on. It would probably be best to pick the last one. Rather than removing the first one. If you remove the first one, do you need to move everything up, or is it just, does it have like an internal index that it just changes? This is where I don't totally understand how spans work on the hardware side, like under the hood. I should read more about it. But that doesn't really matter. That's not the thing we're dealing with. So right now we say, so we pick an initial tile. If we identify that that initial tile has a tile block. So if it has a tile block, we go through this list. We go through this attempt of picking ones that are good. I could do that. I could add an initial check, go through this stuff here. So we go through, we say like while this tile block is not like a tile, is like a solid tile, we erase it. If it's empty, we break, and then if it's not, we go through it again. We set an initial tile. Oh, I need to set the initial tile out here. Oh, I am doing that, aren't I? Initial tile. Oh, I'm setting it in the while loop. That's part of my problem. We need to set that outside of the while loop. And I think I'm just going to take the last one instead of the first one. So we take this one and we say while the count is greater than that. Here we can say while this block has any of this. If it's right, we break out. Problem is if we break out of this while loop, we still hit this, and we'll hit this with an invalid block. I need to prevent that. Why am I struggling with this? I have it working here. I've like slightly changed the structure and now I'm like struggling. What we should do is we should add this infinity loop check so that we don't just crash the whole thing. I can say if partition count is greater than 2000, throw new. I want an error or an exception. What are my options? There's so many options. Should I call it like an overflow? No, it's not really an overflow. I mean, it kind of will eventually be an overflow. Aggregate exception? I could just say exception. Timeout. I could call it a timeout. Timeout exception. Likely infinite loop detected in compartmentalization function of this. Get name, get type name. All right, so we go through here, we remove the initial set. So we do the initial set, which is the exterior flood fill. If we have any, oh, what if unvisited is count as 0 already? So we could say if unvisited count is already 0, well, so if the unvisited count's not 0, then we set an initial thing. And while unvisited count continues to be greater than 0, we run through this loop. So we say while this initial component, if this initial component is solid, we remove it. This is the trick though. It's this removal. If it's removal and now it's 0, we break out, but we're still going to go fall down and trigger this function. I managed to avoid that here by... So we don't do the thing that makes this easy is we don't do this initial loop. We don't do this initial set. We start here. We start within this loop here, this one while loop. But in our new version of it, we do an initial exterior flood fill. Maybe I should do the check here. Get a valid initial one. No, that doesn't address the core problem. The core problem is if we only have one unvisited coordinate left and it's a solid, we need to just get out of here. So maybe instead of break, well, what if it's valid is the thing? Well, I guess in this case, we say return. We don't say break. So there wasn't actually a problem. I'm just an idiot. Because we'll set the initial. We're not going to break out of this while loop. We're just going to end the whole function if we run out of ones to visit. And so here we'll stay in this loop until we either find a valid initial set of chords to start the flood fill from, or we'll just run out of chords and we just end. And then here we do an interior flood fill starting from this initial coordinate. We go through, we remove all of the visited tiles from the unvisited tile list. We increment the partition count, we do a quick little infinite loop check, and then we start this while loop over again, as long as the count is greater than 0. Well, hold on, we need an assignment here. We need to say this. C#, more performant to remove elements from the back or the front of a list. So each time remove at is called, it has to move every element that comes after the specified index up by one element. Okay, so it would be better. It would be better to be working through the back. I love this little trick of doing this, getting this index. I don't know how performant this is, of this like hat one. Which is the last index of it. I could probably just say unvisited.count -1, but I kind of like the shorthand. I don't know if I pay a performance penalty for using that, but. Oh, can I not do remove at with that? Can I cast this to an int? No. Can't cast an index to an int. Rip. So we'd say remove at unvisited.count -1. Remove at index. All right, this will probably work. Fingers crossed. So then in our run function, we say, so we do kind of like what the tile system does. We find our block buffer, we get our span, and then we just do our thing here. We call compartmentalize with the buffer comp. Don't need the span yet. But we could just call compartmentalize with this. This will technically work for now. Running this every frame that the tool system runs, which is a little overkill, but should be fine. Method interior flood fill can be made static. Oh yeah, it can, can't it? In fact, all of these could be made static, couldn't they? Oh, except compartmentalize? What state does compartmentalize access? This? Is it the this? No. Huh. This can also be made static now. Okay, the run, I don't feel like I should mark static. I feel like I shouldn't mark any of these static, but whatever. For now, it's fine. We'll probably add some system state eventually. This will do something. Do we need to change something now? So we need to. I need to change the default block partition to be 0 or to be -1. So we're going to make this optional. I thought I made this optional. Constructor cannot call itself. Oh, we don't need this. That might cause some problems, but we'll see. All right, time for all the bugs. Time to start slaughtering some bugs here. All right, so it thinks everything is inside. Oh, but if you're at the edge, it thinks you're outside. Interesting. Oh, I did this wrong. I remember. So the fill system, so this initial check So the exterior flood fill is actually different. The exterior flood fill is actually, it's going to be a new AABB. It's going to be actually minimum minus vector 3.1 and maximum plus vector 3.1. So it's going to be this. So we're actually going to do this, and we're going to say get non-overlapping with the volume. Do we actually use this anywhere else? Not really. This might have consequences. We check to see if the comp contains it. Okay, no, this lets us just drill in from the outside. Okay, yeah, this is what we want. That should be fine. Crash. Get index. Oh, we're getting an index outside the valid parameter, right? Okay, so fill system. So where are we checking? Where are we doing comp checks? So we're saying comp, if not comp dot contains, yeah, sure. Where are we blindly applying the index? Right here, comp dot get index. So we need to say, we need to add a check. We need to add an if comp dot contains coords. So if it contains, we do these things. We're doing kind of an abusive thing here where we're like checking in areas outside of the volume, where we're using it to like get around so that we can drill in from the outside. But we need to be a little safer about some stuff if we're going to do it this way. So we just do a contains check here. So we basically don't set the partition if we're outside of the span. That is correct. So wait, if this block has any form, so we don't actually want to continue here. This is a solid block. Oh, no, it is. It's right. We don't want to search from a solid block. Correct. Okay. Correct. Okay, so we've done a containment check here. That should be all we need to do for that specific bug. Okay, so we're outside. What if I go up to the edge? Okay, we're still outside. So I'm going to define this area here. And then we're going to go down. Oh, this is, that's strange. Why is that happening? Let's see if I can define an interior space at least. Okay, well, I mean, we can tell this is an interior space, but we're also doing something insane up here. I don't know what we're doing up here. But we're also doing it in a way where... No, okay, we are setting an outline. We're just kind of obfuscating it. Okay, so we're close. Why would we be marking this? It's because we do containment checks from above, maybe? Huh. Okay. That was really weird. Let's try that. Let's try to recreate that. Let's go down a layer, just kind of make a shape and like put a block here. Okay, so it's considering It's considering anything with a greater y and a lesser x as being contained in something. Interesting. Let's double check that the tile system is not insane. Because I did change the default partition number, and I want to make sure that the hull calculation thing is not wrong. Opblock.has, if opblock.isOutside, let's make sure that this function is still correct. So isOutside returns true if partition is 0. But our default partition is now -1. So that could be it. What if I change the partition to be default back to 0? Does that problem go away? Is a good question. Nope. Okay, so that's not it. Well, that's good to know. Although an aspect of the problem did go away. We changed the top of this wall piece to be something else here. So we also recognize, oh, what the F? Okay, so it's, nope. So there's something weird going on here that's crossing, it's crossing the Z index boundaries in a very strange way. Okay. How? I still want to make this partition -1 by default. So the exterior flood fill, we take the composition, we create a new bounding box that is the minimum -1 and the maximum +1. So we're creating a larger area to search. And then we're getting non-overlapping with the volume. So we're basically adding all of, let me make sure non-overlapping works correctly. Because I don't know if it was meant to handle exactly what I'm doing here. If we don't overlap with the other at all, return just the full list. Okay. If our list is new list, so if other dot encloses this, return a whole list. Or return an empty list. Because the whole thing overlaps us. Okay. Otherwise, we go through our set. We say, if not other dot encloses coords, list dot add coords. Okay, this is correct. This will give us a list of all the coordinates that are in our bounding box, but not also the other bounding box. That's what we want, because we're basically carving the middle out of this list, and we're basically trying to get all these imaginary coordinates that are outside of the block buffer's boundaries. So we're basically making this new bigger bounding box and then getting all of the blocks in this bigger bounding box that don't overlap with the actual block buffer volume. So that seems right. We add all of these to the stack and the visited list. So we pop this coordinate off the stack. If our component contains this coordinate set, What is the language of contains? It should be right. Contains is just an AABB enclosed check. And so the encloses is true if coordinates, if we clamping the coordinates doesn't change the coordinates. That's a reasonable check. So if that's true, if the block buffer contains this coordinate, then we get an index. We pull the block out of the span. If this block is not solid, if this block is solid, we just straight up don't search. If the block is not solid. Oh, if the block is solid, we stop all searching. That's right. That's correct. Or we don't search from this block. We don't search from a solid block. And then if it's not solid, we set the block partition to be 0 here, specifically here. That should work. I'm maybe running into an issue because I'm not setting the partition on a block that's solid. And I kind of need to. Because other blocks check this block. Huh. What did we do originally? We were originally doing this. So if a block was solid, we would not fill it. Okay, that's consistent. And that worked. That system worked. Where was I storing this? Oh, I guess if your neighbor block is solid, you just treat it as a middle tile. So that's actually fine. Okay, okay. I was barking up the wrong tree there. The only other issue I see is that there's an issue here where we're... Oh, maybe I'm doing the wrong check here. So when we're doing the Z check, we want not is empty. So if not span is empty. This is also not going to be right later, but it's going to be right now. And you know what? That's good enough. All right, that should be the difference. Oh, actually, I need to change that for the interior flood fill too. That's actually not the difference. I need to also change that logic down here. Because when we're going up and down, we actually care about floor tiles. Actually, how does going down work? Because going down would behave differently than going up. Going down would be like... So when we're going down... when we're going down, we check our own tile, not the next tile. Aha! Okay, and is forward down? Yeah, it is. So we're not going to check comp contains coords plus... Well, maybe we do check this. But here, we're going to check comp span. We're just going to get the index for coords, unless we already have this somewhere. Index. We're going to check span index. So we're going to say if not span index is empty, continue. All right. I'm remembering things I've already written. Oh, do we not have the index defined here? Oh, we might not. Okay. Here we need to do comp.get index coords. All right, that should be it. That was just me failing to write the code as it was previously written. I failed to copy over the code faithfully. We do this and we add a... Okay, so that actually did nothing somehow. Okay. Okay, so interior, so we're not having interference from the other tile, but there's something weird going on here. And it's only going on for the left, for the Y side, for the Y index side. So we have interior compartmentalization. You can tell this block color changed. But if I bust a hole in this, it's not undoing it, which is an issue. This whole thing should be getting gone through and swapped to and getting set to 0 as soon as I bust a hole in it. And then if I go up here and I put a wall up here, we get this, whatever this is. Okay, so there's still something crazy happening here. Is it possibly the search function that I wrote poorly? I very possibly wrote poorly, that I mostly let just the auto fill thing do for me. Wait, is -1 is down right now? Yeah, okay. What if we go... What if we try something? Let's try to identify where the problem is. I'm gonna try to remove the exterior partition. The exterior partition check. That might break some things. Oh, what we should do is set this to 0. So this should work as long as I'm not doing some crazy shit. Oh, curious. Oh, I spoke too soon. Okay, so the exterior one is like super crucial. What if we only do the exterior test and then we just are done? What if we just do this and then return? Okay. That is... Oh, that's behaving super weirdly. So we're not actually checking higher up than this. So we're not actually coming in from the top when we're doing this check here. There's some weird stuff going on up there. Okay, this isn't... We're not seeing this problem, but we're seeing a different problem, which is that we can't actually get into the inner spaces from above when we're doing this. How did that... What's this going on here? Oh, we're not rerunning the... Okay, so that kind of works. It's working along a specific axis. So it looks like the x-axis is behaving well and the y-axis is misbehaving a bit. Perplexing. And so if I try to bust a hole in the wall here, it doesn't do anything. But if I do it here, it can tell and it's like, oh, that's outside. Kind of a janky visibility system. Okay, so why is the x-axis working and the y-axis isn't failing? Why is that happening? Our new volume is in a different space than the old volume, which is potentially an issue. But it shouldn't be because I should be going from local to global space very well. We're only doing the exterior flood fill, so let's figure that out. So there's some problem here. Oh, continue. Continue is wrong. Continue is not the word. Oh god. Okay. If we do continue, we just don't go through the rest of the thing. Continue is correct if this is a for loop, but it's not a for loop. It's a series of if statements. I'm a dumbass. If we change this to be like a loop, where we go through like an array of like adjacent coordinates, then we could hit continue, because we'd just continue the loop. But because this is unrolled, we need to like actually go through and check everything. That is maybe the source of like literally all the problems we're observing. And this might otherwise be correct. Oopsies. Brother, you need some Vim in your life. I'm not a keyboard warrior. Vim would not do anything for me. I'm trash at this stuff. I make do. Is it like you could just invert the if statement here? Yeah, I could. I don't want to for consistency. But yeah, we're gonna just turn this into a for loop. But right now this is fine. And then we're going to copy all of this down because this does not change except in one place. Pretty sure. Except here we can say index. Have you heard the good news? Yeah. You could be a keyword warrior and not be trash. I potentially could. The name is not the Primogen. All right, we crashed. We're not doing a... Oh, we needed to not do what I'm describing here. Comp.contains coords. Oh. This is wild. Okay. These also need to be ands. Oh, or it needs to be and not. We can change this or to an and not. I have a pretty wild keyboard. I should try to be a better keyboard. I have like a Kinesis keyboard, which is kind of insane. It'd be kind of cool if I could learn how to use it better. Certainly be better for like my shoulders and arms. So here we need to add another check. We need to say if comp dot contains coords. Just for this one, we need to like nest this a lot. I should really switch to a comp.tryGetIndex. Should add that. So we don't have to do a containment check first. I didn't do that because I don't like how the maybe not null when attribute works. But I could still do it. I hope that was the exterior flood fill that we manipulated and not the interior one. Okay, so we're hanging. We're hanging and potentially freezing. The compartmentalization thing should detect a loop soon. Should detect a broken loop. Did not. So what happened there? Let's change this to like a much smaller number. Okay, we're getting caught in a loop somewhere. Put a breakpoint here. Okay, we're never making it out of a single loop. I mean, we're maybe making it out of the initial loop. Let's see if we're getting out of the exterior loop. Okay, we're getting somewhere. We're getting stuck somewhere crazy. Where are we getting stuck? We're getting stuck somewhere in the exterior flood fill, where like the stack is never empty, which is understandable. Stack.pop. So we should be popping. Every time we run this, we should be popping something out of the stack. Probably pushing something over and over and over again. We're adding it to the visited, so if the component contains this coord set and the visited does not contain this coord set, then we add it to the stack and the visited. Stack count 692. I want to scrutinize some of this a little bit more. So ABB fill volume is comp.AABB. Flood volume is going to be this new thing. I just want to be able to scrutinize what it is. And then we're going to say flood volume dot get non-overlapping fill volume. Scrutinize these a little more. Okay, so our fill volume is what I expect, 0 to 14, 14, 5. This is also what I expect, -1, -1 to 15, 15, 16, the size of 17, 17, 8, and a volume of 23, so 12. Amazing how the volume almost doubles by just being added 1 in each direction. The last volume is 1350 for 0, 0, 0, and 14, 14, 5. This is 2312 for just -1, -1, -1 to 15, 15, 6. That is why I'm glad we didn't just store a much bigger buffer just for the search purposes of searching. So we're like simulating this. So I kind of want to look at this, I kind of want to look at the stack a little bit. So why does the stack start at the largest possible number, 15, 15, 6? Kind of weird. I mean, I don't care, but it's kind of weird. I would have expected it to start from the smallest number and gone up. These in kind of just random order? No, not exactly. Okay, it goes from max to min, which is unusual, but fine. This is the range I expect. Okay, so we go through this stack, and we never finish? Why do we never finish? We pop something off the stack. Yeah. We do some stuff. There's only 1,000 things in the stack. What's possible is that we're adding things to the stack. Faster than we're removing them. That's kind of the only possibility is that we're adding to the stack basically endlessly. The only time we add to the stack is in these evaluations. Oh, there's a typo. I forgot to remove all of the negations. Oops. Found it. We should go down here and check these because, yeah, these are also wrong. The y-axis ones were going on indefinitely. Oopsies. That should work now. Or it should fail in a different way. Okay, it's working. It's no longer responsive. It is now slow. This is unfortunate. So we've lost a lot of responsiveness. But it should be working correctly. Let's see. Let's go down here. And let's carve a room out. Oh, yeah. It's working. Okay, what if I punch a hole in the wall here? It stops being considered inside. Look at that. And then if I repair the hole, it's considered inside again. All right, we've got compartmentalization. It is very slow. It's like noticeably slow to me. Oh, maybe it's easier. Is it getting cheaper the more full the area, the volume is? That'd be interesting. Let me finish filling out the space and see if that's true. Oh, it is. It feels like it's getting faster the more solid the space becomes. And it's like slow when it's like mostly empty. I guess that makes sense. Oh, this is better behaving incorrectly. Oh no, it's not. It is correctly. We need to think about that. I want to use the maximum. I want to do something about that. The way it's cutting off the sidewalls like this, I think I have an idea. All right, let's try that one more time, and let's go to the edge. Let's go like all the way to the wall. See what it's like. So we'll make a roof. We're gonna use the full volume to make sure that our search around the edges is behaving correctly. It looks like it is. Looks like we're searching around the edge correctly. Yeah, so that's good. All right, that's like virtually feature parity with the old version. The only thing left is camera rotation. We need to be able to rotate the camera. And then, I mean, technically there's the little party trick of being able to lay out a room by just dragging the mouse cursor across and it just makes a room for you. I don't know if I care about that very much. But I'm glad that we've got compartmentalization working again. That seems important. I'm a little concerned with how slow it is when it's mostly empty space, but I guess that makes sense because we're not doing any early out if it's mostly empty space. We could also constrain the number of times it needs to run. Like it only needs to run if it can confirm that there's been a structural change. And we could also, I want to head in the direction of giving some of these things more than one frame to do their job. And it's unclear to me how disruptive this will be in the play mode of the game either. I need to introduce like a representation of the cursor in the grid. I need to add like a grid square thing. It's like a projection of the cursor onto the grid so I can see a little better where I'm clicking. Because I can do this and like have an idea, but see if I do this and then I restart it, like that was pretty responsive, but if I restart it, doors, still need to do doors. Oh shit, you're right, we need doors. Well, at least we'll get triple doors. Yeah, now if I jump across, you can see it takes a while for the thing to catch back up to me. So yeah, there's definitely some slowdown when we're talking about a mostly empty game board. Which is not a big problem because this is an edit time thing. And it's not that slow, it's just slow enough that I notice it. That's part of the reason I picked this 15 by 15 by 5 build grid because I tested larger grids and I noticed quite a slowdown. So I guess we're gonna, oh, that's wrong. Okay, the slowdown is affecting some things. We're seeing a problem. We're seeing a bug that I've fixed earlier. It's back again. It's back for some other reason. It mostly affects when I travel this way. Why doesn't it happen the other way? Huh. Okay, I'll figure that out. It's like leaving material behind, which is interesting, but not what we want. It has something to do with the mouse cursor jumping and the prior bounds. It basically is what happens if we jump more than one tile between frames, which is probably something I should just not allow. Like once we've made a selection, the cursor will just follow the mouse rather than like be the mouse. Yeah, we need to do that too. We need to separate the concept of the cursor and the mouse. Make them two separate things. But that's cool. I'm pretty happy with our progress for today, for Saturday. Ooh, it's been 3.5 hours. That was longer than I intended to stream. But how's it only 3 o'clock then? Oh, because I started at 11:30. Cool. Yeah, this was good. This felt like a good day. We have quite a few people on the Twitch side, at least quite a few for me. So let's see if there's anyone we can raid. I should have some teammates who are... Oh, Average Goob is working on the same game as Two Nerdy Nerds. Oh, their stream just started. Mr. Magoo is in there. All right. Yeah, we're gonna raid the Average Goob. They're doing a really awesome stream game. Or they're doing an awesome game jam with Two Nerdy Nerds who raided us out or raided to us earlier. So we're gonna raid back. I'm gonna set up the raid and put some music on. The Average Goob. I really appreciate everyone spending part of their Saturday here with me, hanging out. We'll be back Tuesday, as usual. We stream Tuesday through Saturday. I feel like after next week, I feel like sometime next week, we are gonna reach. We're gonna exceed the capabilities of our last auto tiling system. It only took a few months, which is an unfair comparison because we built a whole entity component system as well as like the preparation to build a new auto tiling tool. Still need to do doors as well. So yeah, we got a couple things to do next week, and then I think we can finally start moving on to things like pathfinding, like getting characters running around in the ship and stuff like that. And also adding in additional block types like the ones I showed earlier. So that's exciting. I think we've got some exciting stuff coming up. Yeah, we're gonna raid out. Please join me in heading over to the Average Goob if you are able to. Thank you all so much for watching, and I'm gonna see you next time. Bye.